hopefully this is now working. Can you hear me? Can somebody respond? This is great. I can't hear myself coming through the system, and the video is not showing anything, so I'll just have to speak, and we take it as it comes. Okay, so I'm talking about this first presentation results. It goes back to 2015. It's partly based on a presentation I did in New Zealand earlier this year, which is why the coverage is for 2 years pretty much. And it covers some of the events Brad's just spoken about, but it's a global perspective rather than just US or European or whatever. Next slide. This is a plot of the number of occultations observed each year, and on that plot I've indicated when significant star catalogues became available. 2016 we had a record number of observations. It's interesting to note that from 2008 to 2015 the number of observations or successful observations we're getting each year had flattened out. But 2016, with, I suspect, more the interest of Gaia rather than the results of Gaia, has resulted in a significant increase in events observed each year. With that plot, the increase resulting from star catalogues follows in the following years. You can see that in particular with Tycho 2, how Tycho 2 came out in 2000, but it was in the years following that the number of events started climbing. Next slide. This is the number of successful events by region. It's interesting the way this is displaying is different to the PowerPoint that I sent over. That's all right. My original was nicely formatted and this isn't. As you can see, the US last year, 107 events. Previous year, 84, and 25 sites. Japan, small country in longitude, but in fact their success is very high given their the small longitude. Europe is almost as many as the US, and that's to be expected because the size of Europe is similar to the US and Australia, and a good population distribution. Australasia, I think as an Australian we do pretty well because if you know anything about Australia, you'll know most of the country's got nobody living there. We've got a range of people down the eastern coast and then down in New Zealand. Anyway, a total last year of 300 events. Next slide. New double stars. We saw a couple of things from Brad about double stars. Separations are usually in the 0.1 to 0.001 seconds of arc. So typically they're too small to be observed visually through anything but the largest telescopes. But we can get down to separations of below a milliarc second, and the uncertainty in the separation, we're talking about millisecond values if we have 2 or 3 chords. Next slide. This shows the 4 double stars discovered in 2016. You can see their separations. One was Elizabetha. The separation was in fact a very large separation. That was a case where the observer recorded for quite a long time, and he had the main event, and then it was, I think from memory, 30 or 40 seconds later we got this secondary event. The second event there, from Bella, a separation of 10 milliarc seconds, that's smaller than the resolution limit of Gaia. Whereas the last two are just within the resolutions of Gaia. Next slide. Now I'm just going to go through reasonably quickly the some profiles or some plots. So this is the first one. This is beginning of 2016. Here you can see a really poor match to the shape model. Don't know why. That's the best fit I could do, and rotating the asteroid made no difference. And there's an issue with the time base for some of those asteroids, some of those chords. Thyra, again, this is 2 years ago. When you look at the plot, there's a problems with some of the chords. It would seem down at 4, 6, and 7. 4 and 7 would seem to be inconsistent with 6 on the disappearance side. And so that needs there's a general issue of reliability of our chords when we get some of these events. The interesting thing with this event is chords 8, 9 and 10, given this shape model, should have been events. And why not? And there's two possibilities here. One is the shape model is totally wrong. The other is that perhaps the observers for there were looking at the wrong star, or I forget what the magnitude drop was for this one. Perhaps they didn't detect it in a noisy light curve. Now, interesting with this, the 3 satellites systems for giving asteroid diameters, IRIS, Akari and WISE. IRIS and WISE give 55 kilometres, Akari 81 kilometres. My ticks and crosses on the plot, they've been changed with this presentation there, but the Akari diameter is the correct one, and IRIS and WISE are clearly got incorrect radii. Next slide. Chaya, however you pronounce that, a very nice fit to the 5 chords. For this asteroid, this is no other observations of this asteroid. Iris, Akari and WISE all give the same diameter of 88 kilometres. The fit that we get is 95 by 75, which matches those satellite diameters. Next one. Pariana, again, no shape model. A nice fit. I think this might have been one that Brad showed. The IRIS, all the satellites agree with the diameter, and our fit 64 by 39 agrees exactly with that diameter. Next slide. Cleopatra, got their no shape model. Occasionally, a shape model is available on the on Dammit, and my concern about problems with chords 4, 5, 6, and 7. I need to reserve some of my comments about there because, well, chord 1, so chord 2 gives a nice circular fit. Chords 5 and 6, the disappearance is way inconsistent with everything else. It does highlight there is a general issue of making sure that we are certain about our events and not picking out events erroneously in the noise. Next slide. Camilla. Again, well, a nice fit to the shape model. This is a not Dammit, the other shape model, which shows the rotation axis, but it's still the same shape model. It's unfortunate chord 6 had huge uncertainties. When you look at our fit, diameter 227 kilometres, that's consistent with Iris and Wise, but Akari is wrong. I use the word right and wrong loosely here. Next slide. This is an event that Brad showed. The point here, Brad just showed one of the shape models. Most of the Iris, most of the Dammit asteroids have two models, at least two models available. Some of them have 4. The large plot here is one of the Dammit models, which fits nicely. The other plot shows the other model and attempt to fit it to the chords, and you can see it doesn't fit. So one of the things that we get out of fitting the chords to shape models is that shape models inherently or most frequently have 2 valid solutions. There's an uncertainty in the orientation of the axis of rotation, which can't usually be resolved from the light curves. The fitting our occultation observations to the light to the shape models, we can usually eliminate one shape model from the solutions, so it ties the systems down better. And this is clearly a case. Now, with this, the Wise diameter is, well, the diameters for the 3 asteroids which have disappeared out of this plot is 142 for Iris, 147 for Akari, and 143 for Wise. Our fit is 142. All of them fit well. Next slide. Eugenia, quite a nice fit to just 4 chords. And again, an example there at the bottom right is the alternate shape model. And our fitted diameter 184, which matches the Akari diameter of 184. Iris and Wise 206. They're, for some reason, they're more than 10% too small, which is curious. Next one. Patientia. This is again one that Brad displayed. A nice fit. Well, a sort of nice fit. It does. You do get a nice fit of an ellipse to the data, but we have some issues with our video analysis or time base or something. I'll draw your attention to the chords at the middle, chords 15 and 16. And you see there, I haven't got the details in front of me who the observers were. That's not really relevant. This is observer neutral, really. And there's a similar issue with chords 21 and 22 further down. When you look at those two chords, 15 and 16, they're on pretty much the same chord line. You can see on the plot the quoted uncertainty in the event times. And you can see chord 16 has got a significant uncertainty. Chord 15, a very small uncertainty, and probably seems to be, well, it's fairly close to the fitted ellipse. But you would expect that if our uncertainties were realistic estimates, then the uncertainties of such chords should at least abut, but they don't. Now, Chad has questioned whether there's an issue of rotation in time. I suspect that's fairly unlikely. You've got a similar issue if you drop down to chords 21 and 22. Chord 21, the reappearance hugely after chord 22, and the small time difference between the events, which might have been 5 or 10 minutes, doesn't explain those differences. There are issues that we have which we need to look carefully at in terms of ensuring we've got the proper time base, and also how we get the extraction of the event times out of the noise. But this is an example of a situation which highlights this as an ongoing issue. You'll find events like this scattered throughout the data set. We're much better than we used to be, but there's still room for improvement and probably pragmatic dealings with what our real uncertainties are. Next slide. Calliope. We had 2 occultations of this in the course of 6 weeks. The 2 events are plotted to the left. The first one, which has only got 4 chords, the top one, best fitted diameter of that is 161 kilometres. The second event, the best fit 152 kilometres, and it's interesting to note that the top one, the chords fit the shape model quite nicely. When you look at the bottom one, where you've got a large number of events with significant uncertainties, the fit is not as good as the event with fewer chords. You know, we can argue about which one of those is really the best fit, but one of the interesting things there, taking those measured diameters, saying the diameter is somewhere between 152 and 161 kilometres, you come to the conclusion that the Akari diameter was too small, and Iris and Wise are a little bit too large. So that's an illustration of some value and of analysing multiple fits to shape models, and it's something we need to start doing more of. Next slide. Mandeville, no shape model. Best fit 120 by 98. I had a look at some other fits. There's two other well-defined events, 124 by 84, 138 by 85. All those fits are consistent with a diameter of around 110 kilometres. A car is too large, Wise and Iris, well, Wise might be a little bit too small, Iris is about right. Next slide. Ursula. No other events for this. 114 by 92. It's an interesting distribution of chords. In terms of a fit to shape models, it'd be nice to have a shape model for this, because chord 1 would suggest that the asteroid is anything but elliptical. Now, Chad's asked the question, maybe we should be taking into account profiles presented when Iris, Akari and Wise made their observations. Could have presented a larger, warmer side then. I think the issue with the satellite observations is they're not based on a single measurement of the brightness. I'm not quite sure how they do it, but I'm fairly sure they have multiple observations of the asteroids to get their diameter, and how you'd find out what the orientation was when they did their measurements. Well, somebody can do some research to find out whether that's something that should be extracted. Okay. Next one is Juvisa. No shape model for this. A best fit to the positive chords gives an ellipse, which is 79 by 66, which fits Iris and a bit too large for Akari. But geez, there's 2, 4, there's about 7 missed chords at the top end. That's problematic. If we're getting a shape model fit, an ellipse fit, which is consistent with the satellite diameters, that sort of suggests are those miss chords actually misses? Because otherwise, if you say, okay, that wasn't a fit, those were genuine miss models, then the asteroid is presumably somewhat longer in and out of the page, and that would suggest that the asteroid is significantly larger than the satellite diameters. So a bit of an issue there. Don't know what's going on. Have to watch that one with interest. And unfortunately, there have been no other observations of that asteroid. Next one. Brad spoke about this at length. That's the satellite discovery. It's congratulations to all involved, and this really does highlight the importance, well, a situation where a miss event can be the most important event of the whole lot. Next one. Xanthippe, quite a nice fit there, no shape model, 114 by 95. Other events, 126 by 103 and 110 by 110. That would suggest that Wise at 111 has probably got it about right. Iris at 121 is too large, and Akari, maybe right, maybe wrong. Next one. Skip this one. I forgot to. Well, no, I haven't got. I've been putting this together the other night. I didn't put the right slide in there. 79 by 64 kilometres and a reasonable fit. The last profile I have is one we did here in May. It's only the third Plutino, that's asteroids out around about the orbit of Pluto with the 3-2 resonance with something or other. We managed to get 2 chords for this. You can see the very left is, I think we had 3 miss chords at the top, 1 at the bottom, and 2 hit chords in the middle. Number 5 was from John Newman, who's listening into this. And the chords are clearly indicating the asteroid is non-circular. The middle plot there is a best plot assuming the ellipse is aligned along track. And then I did a sort of fit across with the ellipse sitting across path. More when I looked at the magnitudes of this asteroid from the astrometry that's been done on it, there's no evidence of large magnitude variations in the rotation. But you can see there the diameter is something of the order of 130 kilometres, and that's an important thing. The people at Paris Observatory are keen for me to write this up and get it published because it's a significant event. And that takes me to the final thing, which is any questions. I guess thing I want to emphasise, a point I want to make with all of this is we've been observing these with video now for 15 years. We're getting a significant number of asteroids with multiple events, and when we have shape models available for those asteroids, we can fit the shape models to the events and start deriving the diameters for each of those events and starting to come up with a true measure of the asteroid diameter, or a far better estimate of the asteroid's diameter than you get by just analysing a single event. In all of this, single chords are useful for, if the asteroid hasn't been observed before, to put some sort of minimum size on the asteroid, but we need really to have at least 2 chords, to well-separated chords, so that we can do some sort of reliable fit to a shape model. As was seen by one of Brad's presentation fits, when you have an irregular shape model, and most of them are somewhat irregular, it does become feasible in many circumstances, to do an accurate fit of two chords to that shape model and thereby derive an accurate diameter for the asteroid. So I want to emphasise in all this that, well, some of the things I want to emphasise are the need for us to work on inconsistent chords that we're seeing in our observations, to identify the cause for those inconsistencies and get our timings it's not more accurate, but we need to understand what's happening in timings and not have situations where two chords which are co-aligned are inconsistent. That's a fundamental problem we need to work on. And whether it's uncertainties or time-based issues, we need to understand what's going on there. But then on data analysis, whilst we spend a lot of time in analysing our individual events, we are in a position where we need to start moving into people taking on responsibilities for, I am going to look at this asteroid and investigate all the occultations we've observed of this asteroid and come up with the best fit out of it all. So, questions?